Hello, and today we're going to learn how to solve literal equations. A literal equation is an equation which has a bunch of letters in it instead of numbers. It actually might have a combination of both of them. But the solution of a literal equation is not going to be a number. You're not going to get x equals 5. You're going to get another equation, but the goal is to just isolate one piece of the equation. For example, if I said solve for b1, if you have this equation, the new equation would look like b1 equals, and then it'd be all in terms of this other stuff, but you're not going to get a number. We're going to end up solving this for b1, but to start, we're going to look at an easier one. All right, so again, the idea of solving a literal equation is to use the addition and multiplication property of equality to isolate the desired variable. So for this example, the desired variable is r. Solve for r means we want r equals something. All right, so currently there's a 2 and a pi attached to the r by multiplication. Hopefully you recognize this equation, by the way. This is solved for c. So the circumference of a circle is equal to 2 times pi times the radius of the circle. Say we wanted to solve for r instead. So we know the circumference, but we want to find out the radius. Well, it would help us to have this as r equals. How are we going to get r equals? Well, r has a coefficient of 2 pi. So if you recall the multiplication property of equality, if we multiply this by the multiplicative inverse of 2 pi, which is 1 over 2 pi, okay, we're going to end up getting 2 pi over 2 pi, which reduces to 1. Beautiful. But if we do multiplication to the right side of the equation, we also have to do it to the left side of the equation as well. Okay, so notice I just multiplied the left and the right side by 1 over 2 pi. On this side, really nothing happens, or you can rewrite it this way, and I would, c over 2 pi. And then on this side, 1 over 2 pi times 2 pi would give you 2 pi over 2 pi, which reduces to 1, so you just get r. So here is the literal equation solved for r. r equals your circumference divided by 2 pi. Okay, let's look at one that's a little bit trickier. In this case, we're asked to solve for h. See if you recognize this equation. It's the surface area of a looks like a square prism. I think that's what this little guy right here is. Surface area. In any case, to solve for h is right here. We have this unnecessariness over here, and we have this coefficient here. So we're gonna have to take care of both of them. Let's start by getting rid of this. What can we add to this side to get rid of the 2s squared? What about negative 2s squared? So then the negative 2s squared and the positive 2s squared will become 0. Now just be careful, we have to add that negative 2s squared to the other side as well, because of the addition property of equality. So now this becomes 0, this becomes negative 2s squared plus a. We can also reverse these two terms, so we have a plus negative 2s squared. Doesn't matter. To make it look pretty, I'm going to write it like this. And then this side is 0 plus 4sh, or just 4sh. All right, we need now 4s is a coefficient of h. We need to get rid of the 4s. So what are we going to do in order to get rid of the 4s? We're going to use the multiplication property of equality. We're going to multiply this whole side by 1 over 4s, because that's this multiplicative inverse. And we're going to multiply this entire side by 1 over 4s, because that's its multiplicative inverse. So on the right side, 4s over 4s is going to reduce to 1, so we have just h on the right side. Yay! Over here, nothing reduces, and we're going to multiply this thing by 1 over 4s. What's going to end up happening is this term, which is really over 1. The a minus 2s squared is going to go in the numerator, and the 4s is going to go in the denominator. So here is the equation solved for h. So the height of a square prism is equal to the surface area minus 2 times the side squared divided by 4 times the side. Not something you have to memorize. I wouldn't expect you to. But this is how you would solve for height if you were given everything else. All right, and then the one that I introduced at the very beginning of the problem. Area, and this is area of a trapezoid, is equal to the sum of the bases divided by 2 times the height. We want to solve for base 1. Okay, so the first thing we need to get rid of is, well, why don't we do this? Let's get rid of this thing right here. It's being divided by 2 and multiplied by h. What you can do, let's not do it that way. Let's first just get rid of this 1/2. What is this? Let's rewrite this as 1/2 of b1 plus b2 times h. Okay, because anything divided by 2 is the same as that thing multiplied by 1/2. So we can multiply the both sides by whatever the multiplicative inverse of 1/2 is, which is 2. So if I multiply the whole right side by 2 and the whole left side by 2, I'm going to get 2a over here, and then I'm going to end up getting 2 times 1/2 is just 1, so I'm going to get b1 plus b2 quantity times h. There's no distribution to happen here because we're multiplying it by, this is all one term because it's all multiplication. 1/2 times this thing in parentheses times this, so there's no distribution. We also need to get rid of this h out here, so we need to multiply this side by its multiplicative inverse, which is 1 over h. This side by its multiplicative inverse, which is 1 over h. So we end up with 2a over h is equal to b1 plus b2. And the very last step is just to isolate b1. Let's subtract b2 or add negative b2 to both sides because that is its additive inverse. So we finally have b1 by itself. And I'm just going to reverse the order of these, make it 2a over h minus b2 is equal to b1. And we have isolated, we have solved for b1. Okay, so that's how you use the addition property of equality and the multiplication property of equality in order to solve for a single variable.